Hello everyone, in this video tutorial I'm going to introduce you a new plugin called Cyclic Load Creator for ABAQUS software. Cyclic load analysis is very common for earthquake assessments, and it's very easy to conduct for any type of structures or elements, beams, columns, slabs, shear walls, beam column joints, any kind of even multi-story frames as well. So when you do experiments, so particularly you want to develop a finite element method model as well, so it can help you. Additionally, it is good to create CSV for your experiment as well. And the plugin is utilize two type of codes. One is FEMA 461 and ATC-24, which is very common in seismic or quasi-static experiments. And you can go read these documents, and additionally there's a lot of paper as well. And today I will create the amplitude, and I will apply to this simple model. This is a beam column joints, CFST actually, CFST beam column joints. And then we will plot the stress response and also the time history of which we create by this plugin. The first thing is you should name your model. In case if you have multiple models, you name it, write the name. And the second is you can give a name for amplitude that you want to create. Here is new amplitude right now, so I keep it as a default. And this is called the length of displacement. So I want to give my length from this point to here, which is 1200 millimeter to face of the column. In case if it is a multi-story frame, give the height of the frame. And now here I want to change it to 1100. Now you must give how much percentage or percent drift you want to pull your structure, and additionally all the target displacement. So I'm going to 5% of this one, and then this be 60 millimeter, and the program automatically will create the time history for me. There is one more thing, and in the simulation we need time steps as well, so you can give this time steps automatically. It's starting from 1 second, and then the maximum displacement is about 60 millimeters, so it has about several cycles, so it will create maybe 1 minute or maybe 100 seconds, or we can later find out how many seconds for this displacement will determine. Additionally, you can export the data in your program also for Excel as well. So now I'm going to consider the time step is 1 second, create, and the program automatically created the amplitude for me. Here you can see the displacement, positive, negative, based on the AT-24, and the total time step is 76 seconds, which you will need for your step. So in the step, you need this 76 seconds, and then based on that 76 seconds, you can see the level of loading speeds. So now we applied the cyclic load here. If we go back to loading, this is the loading, and it's actually a simulation based on experimental work. And then we actually completed the analysis. The analysis completed, we're gonna go to results, and you can see the final step is 76 seconds, and here we can see the results. And now in case we want to see the mesh, we can go to the option and see the mesh as well. The mesh. Now we can go to the displacement. So local displacement is here, which is local buckling of the CFST column. Additionally, I want to cut, and I want to see some sort of damage in the concrete. So here is the tension damage, because when we apply the load, it becomes changed to moment, and then those moments will be distributed to the tension in the flange area, and then stretching this area, so it's become quite tension damage of the concrete. So additionally, we can go to the compressive damage of the concrete. It's also concentrated here. We come to the slip area, because between the steel and the concrete is some sort of slip. We introduce slip. Yeah, you can see the stress and slip deformation here as well. This is one of my work for my paper, so you can actually get this data and join my YouTube channel, and in case if you need. Additionally, you can see other parameter, for example, stress strain. and the ultimate strength is reached to about 500 or 475 megapascal, which is the yield point. And we go to the hysteresis response. Hysteresis response, we create hysteresis response from this point. So already we have introduced a set, which is the U2 RFP in the vertical direction. So save it as a XY combined with a slope, and we get this hysteresis response. We can export this to Excel, and I have already exported. Here is the hysteresis curve, and we made one simple division here by 100 to get a kilonewtons. So now it's the vertical is y direction is force, and the horizontal is displacement, and we have the hysteresis response. So we applied this cyclic loading to the beam column joint in the end of the beam, and then we got the response. So it's quite simple and easy to create this cyclic loading and to do a cyclic analysis in your ABAQUS software. Additionally, you can copy these time steps and give to your actuator when you do a cyclic test or precise cyclic test. So it's quite easy. Now you can receive this plugin by joining my YouTube channel. And if you have any question, please put in the comment and I will find time to answer you. See you next time.